Welcome. This is the first lesson in a new unit on a concept called inheritance. Let's get started. We've got three learning goals today. The first is that we need to be able to explain the purpose of inheritance as it relates to computer science. We'll also see some new vocabulary, and we need to be able to create things called a superclass and a subclass using the word extends. Finally, we want to be able to design class hierarchies that maximize the reuse of code. Suppose we wanted to make a class to model a person. Now, we know when we create a class, we have to determine what instance variables are in that class. In other words, what are the attributes, what are the things that a person would have? And we could probably come up with all sorts of things, right? You know, a name, an age, a job title, etc. But for our purposes, let's have our person have two instance variables, name and birthday. Now, we also know that when we're writing a class, in addition to the instance variables, we'd probably have some methods as well, maybe a constructor, maybe setters and getters. We'll get to that in a little bit, but for right now, let's just think about the instance variables. And like I said, we're going to go with name and birthday. In this scenario, name and birthday represent what are known as has-a relationships, in that each person has a name and each person has a birthday. And has-a relationships are always going to be represented by the instance variables of our class, right? And we've done this before. For example, we might say that a rectangle has a length and has a width because those would be instance variables in the rectangle class. Even though we haven't used the word for it, we've really dealt with has-a relationships since the beginning of this course, right? From the first time we ever saw a class, has-a relationships were a thing. But now we want to introduce a new type of relationship called an is-a relationship. And this type of relationship happens when one class is a more specific example of another class. So in this case, we've got a person. But what if we had another class that is called student? A student could be a more specific example of a person. Let's look at this idea of an is-a relationship visually. So on the right, you can see that we have this idea of a person. And then inside, we have two more specific examples. A student is a person, and a worker is a person. So again, student and worker are more specific examples of the bigger person. Now, this is-a relationship doesn't work both ways. We can say that a student is a person, but we can't necessarily say that a person is a student. Some people are students, but not all people are students. The problem we see when we have is-a relationships in computer science is that it has the potential to create a tremendous amount of redundant code. So we have a person, right, and they have a name and a birthday. But then when we have a student, and a student is a more specific type of person, they also have a name and a birthday. And it's not just the instance variables that may be duplicated between these two classes, but also methods like setters and getters. So if we had a setter and getter for both the name and the birthday, that's 4 methods and 2 instance variables that are repeated verbatim between the two classes. And this is really just a small example. Imagine if we had several other classes that had is-a relationships with more instance variables. How much code are we repeating verbatim over and over again between classes for these is-a relationships? And honestly, it could be hundreds or thousands of lines. So is-a relationships can be problematic from a repeated code standpoint, and we need a way to solve that problem. With all this in mind, we now introduce the idea of inheritance. Inheritance is a technique in computer science where we can create these is-a relationships but avoid the redundant code. And the way it works is this. On the bottom, we have what's called a subclass, and this is our student class. And we see that a student class has 2 instance variables, GPA and schedule. At the top, we have what's called a superclass, and this is our person class. And we can see that a person has 2 instance variables, name and birthday. Now, notice that in the student class, I did not duplicate the name and birthday, right? There's only 2 instance variables here, not 4. And that's because The inheritance relationship allows the student class, the subclass, to inherit, to obtain all of the variables and methods of the person class. So what that means is that the student has a GPA and a schedule, plus it inherits the name and the birthday from the person class. Without inheritance, my classes are going to have repeated code. We have a person with a name and a birthday as instance variables, and then we have a student. And a student is a type of person, but then we have to duplicate that name and birthday instance variable and all the setter and getter methods that go along with it. However, when we use inheritance, we're able to create the two classes, but we're able to avoid the repeating code because the subclass student automatically gets everything that the person, the superclass, has and does. So my student class, it looks like there's only 2 instance variables there, but there's actually 4, and it happens automatically. It's often the case with inheritance that multiple classes can inherit from a superclass. And so you can see this example. So the superclass is still person, and all persons have a name and a birthday. But we have some subclasses, student and worker. Student specifically has a GPA and a schedule. Worker specifically has a title and a pay rate. But both of those classes also have a name and a birthday because they inherit it from the person class. It's even possible to have more than 2 levels of inheritance, and we can see that. Again, person is still our superclass, and we have subclasses, student and worker, but if you look all the way down, we have a class called high school student, and a high school student is a student, and a student is a person. We could even say that a high school student is a person. And it looks like high school student only has 2 instance variables, class rank and the honor roll, but they also have a GPA and a schedule that's inherited from student and a name and a birthday that's inherited from person. So when I go to write this high school student class, I'm only working with 2 variables, but I'm actually inheriting 4 more and possibly 8 setter and getter methods that go along with them. And hopefully now you're starting to get the idea of how much code you can actually save using inheritance. At this point, we need to dive into the code and see how we create these inheritance relationships. So on this slide, we see our person superclass. And the superclass is where we want to put all of the things that all persons have in common, whether they're students or high school students or workers or whatever, all things that are persons. This is the common attributes. And in this case, we just have 2. We have the name and the birthday instance variables, as well as the setters and getters that go along with it. To create a subclass, the inheritance relationship, all we have to do is use the keyword extends in the class header. So you can see that we've said at the top, public class student extends person. And student has its own instance variables, GPA and schedule, but it now also inherits the name, birthday, the setters, and the getters from the person class, which means we avoid repeating code. To see how all this fits together, let's walk through some example code. So the line of code I have is student s equals new student. So I'm creating a student object. Keep in mind that student is the subclass. And you can see from the memory diagram how we do have the GPA and schedule, but we also inherit the name and the birthday. Moving forward, you can see that I am able to call methods on my student, like set GPA to 3.9. You can see that get set over here. And set schedule. You can see that get set right down here, band, computer science, and art. I can also set the inherited name and birthday. So I can set the name to Molly. You can see that here. And I can set the birthday, in this case, to September 15th. And so when I create the student object, I have access to the student things, but also the inherited things. For the understanding check today, I really want you to process the concept of inheritance. Writing the code isn't particularly difficult, but the concept and how it all fits together can be a little tricky. And so on the right side, I've got an empty class hierarchy. You can see that I've got a superclass at the top and two subclasses that inherit from it. And I'd like you to fill those in with literally anything. The only thing you really have to pay attention to is the fact that in the subclasses, we want to have is our relationships with the superclass, right? Like a student is a person, a worker is a person. We also want to make sure that the superclass has common attributes. So all persons have a name and a birthday. And the subclasses then have those unique attributes. Like for a student, it was a GPA. For a worker, it was a pay rate. And I just like you to kind of come up with your own example. It's not something we're ever going to write code for, so you don't have to think like that. But just really try to think about those is our relationships and come up with something so that you're making sure you understand how these relationships are supposed to work.